learners, today we are going to study combined variation. So here, what is a combined variation? It is a combination of direct, inverse, and joint variation. We can have direct and inverse. We can have joint here in the direct and an inverse. So that's combination, and we call that combined variation. Okay, let's have number one example. We have D varies directly with E and inversely with H. So let us write that one in a symbol. D varies directly, so we put this one here. Direct is above the fractional bar, E here, and inversely is down, H here. And in symbols, D is equal to, we introduce the constant K, or the variation constant, K times the E and the H. We solve for K, we multiply H to D and multiply E down here. So our K here, the constant of variation, is equal to D times H over E. That is our variation constant K. So we have that number one, the joint between the direct and the inverse. Number two, F varies directly with B and inversely with C and the square of D. So we have direct B only, inverse is C and D. So in simple class, we have F symbol varies with B up, because directly is up, and inversely is down. So we have C and the square of D. How do we write the square of D? So we have D squared. Then we write that one in equation form. So we have F is equal to, then we introduce our constant of variation K here times the B and then C D is squared. Multiplying this one, there's 2, so we have KB over CD squared. And then solving for K, the constant of variation, so K is equal to, put the fractional bar, so we have F above here times the CD squared. So we have CD squared over down the B, so we have B. So that is the equation for the constant of variation K, F CD squared over B. Okay, let's solve number 3. So here class, we will form first our equation. But first, we write it in symbol. Z varies inversely with X. So here class is have Z here. So here. Inversely means we are going to put it here. Now with X here. And directly with Y. So Y is up here. Okay, then in equation form we have K. We can here because k is always above, and then y, and then we have our x. Then we solve for k. So k here, put here plus k is equal to zx, or xz over y. First we solve for the k. So here no problem. If x is equal to 1/2 and y is equal to 5, then z is equal to 20. So we put here the z is equal to 20 times the x, which is 1/2, over the y, which is 5. 20 times 1/2 is actually 20 divided by 2 is 10 over 5. And 10 over 5 is equal to 2. That is our a. Then we are going to solve x when z is equal to -4 and y is equal to 8. So here, because we are solving for x, we can use this equation here, z is equal to ky over x, or we can use this one. So maybe we can use this one. We can use this one or this one. Okay, let's use this one. Z, cut here, we have unknown, we have the z and the y here. So the z is -4. So I'm going to put here -4 for the z is equal to, okay, here. What is the k? K is equal to 2. So we have 2. What is the y here? Is 8 times 8 here. And then the x is here, and that's we are going to solve for x. Now we cross multiply. We multiply x up. We multiply -4 down. So we have here, the x is here. Okay. 2 times 8. Can we multiply 2 times 8? 2 times 8 is 16 over the -4. So our answer is -4. Okay, let's have number 4 class. If 20 volunteers can wash 100 cars in 2.5 hours, find the constant of variation and find out how many cars 50 volunteers can wash in 3 hours. So here class, let's have V for volunteers, C for cars, and for hours, let's have T for time. We have V here. What can you say about the volunteers and the cars? Are they directly proportional or are they inversely proportional? When we have more volunteers, they can wash more cars. If we have less volunteers, they can wash only less cars. So they are directly proportional. What about the volunteers here and the time? If we have more volunteers, then the time will be lessened because there are more volunteers, more workers to work. If we have less volunteers here, it will take longer for our time to finish the work. So the volunteers here is inversely proportional to the time and directly proportional to the cars. So let us write that one in symbol. We have the V here, varies. Then we have for the cars C, which is direct. And for the time is here. So our V is directly proportional to the cars here. The volunteers V is inversely proportional to the time. Now let us write that one in equation form. We have the V is equal to K times the C over the T. And then we solve for K. So cross multiply T multiply to V, the C multiply here, down here. So our K is equal to volunteers times time and then over C. So let us solve for K. So our K, back here guys, K is equal to V. How many volunteers? We have 20 times, what is the time for this 20 volunteers? 2.5 hours. So multiply by 2.5 hours. And then the C number of cars is 100. Alright. Always check the units. The units must be the same. So we have here, we can cancel the 0 here and the 0 here. And 2 times 2.5 is 5. Over 10 here. So our constant of variation is 0.5 or 1/2 if you want 1/2. Okay, let us find out how many cars 30 volunteers can wash in 3 hours. So you can use that one or you can use this one. So let us use this one, this equation formula. K is 0.5. So here we have 0.5. V. Volunteers now is only 30. Greater than 20 is 30. So we have 30 here for the volunteers. Okay. Times the time. In 3 hours. So we have here 3 hours. And then how many cars? So our C is the one that is unknown. So cross multiply. This is over 1. Multiply C to 0.5. Multiply 0.5 down here. So our C is equal to, can you multiply 30 times 3? Yes. So we have 90 here and then 0.5 will be here. And 90 divided by 1/2, 90 times 2. So our cars, so our C is 180 cars. So if we have 30 volunteers, this 30 volunteers can wash 180 cars in 3 hours.